shit. Yeah. Fine, that doesn't matter. So how will solve this? Let's take area number 1, 2, and 3. We'll add all this. So first one is 2 into 2 plus 2 into 1 plus half into 1 into 1, which will give you 2 plus 2, 4. 4. Did I miss any number? No, yeah, 6, not 4. 6.5, yeah, joule. Okay, so work done equals to change in kinetic energy. So K final minus K initial. So K initial is 0, therefore K final is the work done, which is 6.5, which is our option C. That's it, easy. So let me choose another one. Okay, there is a little bit derivation required here. Question 2. Okay. So what you will do here? So here what's happening? Linear momentum, a body of mass with an unknown velocity undergoes a collinear collision with a body of mass m2 moving with a velocity v2. After collision, m1 and m2 moves with the velocities of v3, v4 respectively. Okay. So 1 and 2 undergoes. Okay, so let me read again. A body of mass m1 moving with unknown velocity v1 undergoes a collinear collision of a body of mass m2. Okay, so 1 is colliding with 2, moving with velocity v2. And after collision, m1 and m2 moves with the velocities v3 and v4. Yeah, easy. If m1 and m2 are 0.5 velocities and masses ratio 0.5. Very good. So what's the v1? So here, we need to just use the formula v1, v2, m1, m2. It's very easy. Come on, before collision, after collision. M1 U1 plus M2 U2 equals to M1 V1 plus M3 M2 V2. Solve it and do it fast. Don't take much time here. M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. And M1 here, M1 only. U1 is here V1. So M1 V1 plus I cap, don't forget. M1 V1 I cap plus M2 V2 I cap equals to M1 V3 I cap plus M2 V4. So ratio of M2 and M1. And V1 here, let me write this. Hmm. No, this is V2 value. I'm sorry. I got wrong here. V1 as it is. M2 is 0.5 M1. V2 as it is. M1 as it is. V3 is 0.5 V1 plus M2 is 0.5 M1 and V4 we don't know. So you will get in terms of V4. So V1 in terms of V4 you will get. Yes. What is the value you're getting? A, B, C, D. Which option? Yes, guys, come on. Which one you're getting? Are you able to solve or shall I solve fully? Shall I do it complete answer? Yes.
So can you explain how you got the equation again?
This equation? Okay.
Yes, sir.
Sure. So this equation, let's start with the basic equation first. What did I click? Okay. So initial momentum should be equals to final momentum as per the conservation of momentum. So initially there are two particles. So one is in one condition, one is coming and striking it. So M1 mass for first particle, velocity of at initial stage, then mass of second particle, velocity of its second particles at initial condition. Then now this is colliding, equal to means it's colliding now. After colliding, mass of first particle into velocity after collision, that is V1, plus mass of second particle after collision of first and second. What is happening to second particle? That is V2. Right. V2. This is our condition. Right. Now, what are things given? This one we have, this one we have, and V3, V4. So M1 as usual. U1 we have, that is V1 I cap, it's given here. First we used, second one plus M2 undergoes collision with the mass M2 and velocity V2 I cap. Then M1 after collision, it becomes V3. Then M2 after collision, it becomes V4. Now, what's the condition given here? Condition is if M1, I'm sorry, M2 is equals to 0.05 M1 and V3 is equals to 0.0, 0.5, not 0.05, 0.5 V1. Now let's substitute M2 and V3, remaining as it is. That means we are getting all the values in terms of V1, we are getting M2. Let's substitute first, then we'll see. M1, what is V1? As it is. Plus M2, 0.5, M1, V2 as it is. Equals to M1 as it is. V3, instead of V3, we are writing 0.5 V1 I cap plus, so actually this all are I cap, so no need to write. It's making first here. M2 is 0.5, M1 and V4 as it is. So we have M1 everywhere. Let's cancel this. So V1 plus V2 equals to 0.5 V2. I forgot here. Okay, you don't forget while writing. 0.5 V2, which is equals to 0.5 V1 plus 0.5 V4. Then M1 should be also same. Okay, no problem. Not a problem. Okay, so V1, let's move this side and let's send this V to that side. So V1 minus 0.5 V1, which is equals to 0.5 V4 minus 0.5 V2. This will be 0.5 V1, so 0.5 common, V4 minus V2, 0.5. So V1 is D option. V4 minus V2. That is V1. Understood, everyone? Are you facing difficulty? What happened? Busy in writing?
Understood, sir.
Understood? What about others?
Understood, sir.
Okay.
Understood.
What about Tanishq? Is he there? Okay. If you can't answer, you can text also. Okay. See, actually, this coefficient of restitution is not there in like school syllabus, but we have for JEE exam. So let's use that question, and with this, you will have one revision for your formula also. If you don't know formula, I'll just tell you formula. Okay, so let me just paste a formula. Yeah. I don't want to type. Yeah. Here E equals to 1. Remaining condition is given in question. Now try to solve it. Come on. I'll just drink water. Yes, guys, any progress? Yes, guys. What's your answer? A, B, C, D. Which option? Need any help? So what they're saying is 1/4 of the original speed and mass of second body. Okay, it's very easy. You should get this. See, if we take first velocity as v, second as v1, or first as v1, like whatever. Here we have formula v2, right? So let v2 and v1 is 1/4 of v. v2 is like v something. So v and divided by u1. u1 is what? Initial, is moving with velocity. Okay. Oh yeah, yeah. So restitution E equals to 1 only. Second one. Yeah. Are you able to solve or not? Come on, guys, tell me so I can understand what shall I do. Texting. Yes. Adesha, Anjali, Pravalika, Ramcharan, Sainyati, Shruti, Tanesh, Vishwanath. Are you able to solve? Tanesh, I could not hear what you said. Your audio was so low. Say again. Are you a flash or what? It is moving in fraction of a second. Okay, then let me solve. Fine. कुछ तो बोलो. इधर गए बच्चे. So this object is colliding with this one. What's happening with the screen? Let's take mass m and some mass. This one, second object. Fine. The mass of small body, because we have one object, right? So mass of one small body. Let's take as m and another one m. Before collision, after collision.